Hello, and welcome to a short teaser video for offline recommender system evaluation under Unobserved Confounding. My name is Olivier Jeunen, and this is work that Ben London and I did in collaboration. In a recommendation system, we typically have some notion of a reward, which can be influenced by certain actions. These actions are decided by a policy, and we'll call the current version of the system our logging policy. Very often there will be some features, like a certain context, that influence both the reward and the decisions that a logging policy is making. Making things slightly less abstract, you can think of them as features that inform a production system which recommendations to show and how they satisfy the user. For the system we have in place, we can then easily measure how satisfied users are, as the expectation of the reward, given that actions are sampled according to the logging policy. Now, the key question that you want to answer with offline evaluation is what the expectation of the reward would be if we were to intervene on the production policy and sample actions according to this new policy instead. Now, this quantity is non-trivial to estimate from logged data. But luckily for us, off-policy estimation techniques have been proposed in the literature to answer this question. Methods based on inverse propensity scoring and doubly robust methods in particular allow to recover unbiased estimates of this quantity. Now, a big assumption that is often swept under the rug in these works is that we have no unobserved confounders. That is, there are no unknown variables that influence both the production policy as well as the reward. You might think of these as features that were used by Pynot that we don't know about. In industry, this might occur when the logging policy is quite complex and we need to estimate it from log data. In academia, when we rely on publicly available datasets, the logging policy is unknown and we need to estimate it either way. This implies that seemingly harmless statements you might see in research papers like, for simplicity, we assume that Pynot is non-personalized, now leads to biased estimates of metrics, which can significantly impact offline evaluation results. The key contributions of our work include that we highlight this important issue, which is often overlooked in the literature. We quantify the bias that naive IPS estimates incur, and we prove that existing diagnostics that are used to validate propensity scores cannot uncover this. On synthetic data, we show that IPS estimates in the presence of unobserved confounders can be arbitrarily bad, highlighting how problematic the situation can really be. We hope to cultivate an awareness of this issue among researchers and practitioners. Thank you for listening, and we hope to see you at the workshop.